Hey guys, we're going to do a quick review over Unit 5.1. The entire Unit 5 has function operations and division, so we're just doing the key characteristics for this first test. The next test will have everything else. So let's go ahead and jump right in. Number one, identify the following. It should say M behavior right here, and it does not. Then also, is this function even or odd? Is this function negative or positive? So let's just get right into it. We are looking at the arrows, the end behaviors. So if we look, I'm looking first as the x's approach, as the x's are approaching infinity. So positive numbers, this side of the graph. The right side of the graph, what is my arrow doing? Is it facing up or is it facing down? It's facing up. So positive infinity. And remember, I would suggest doing this review first and then coming to look at the video because you might not need help with all the problems. You might need help with one problem, so you can skip through the video. Okay, so next one. Looking at the left side of the graph now. Is that arrow facing up or down? It's facing down, so the y values are going towards negative infinity. So then next, is this function even or odd? So we know that odd functions are have the ends are facing opposite directions. So this is odd. Is this function negative or positive? Memorizing my chart, I know that positive is like this. And you can kind of, honestly, the easiest way to remember that is this is a positive slope. So when it increases left to right, so that's how I know it's positive. Erase that. Okay, let's move on. Number two, similar question. Identify the following: M behavior and even odd, negative or positive. So I'm looking first at my arrows. So on the right side of the graph, what is happening as x is going positive or towards positive infinity? My y values are facing downwards, so negative infinity. The other side, as the left side of the graph is getting more negative, or as x is approaching negative infinity, f of x is facing which direction, up or down? It's facing down, so it is also heading towards negative infinity. Is this function even or odd? So both arrows are facing the same direction, so even. And then is this function negative or positive? This one would be negative because it's facing towards the negatives. So then it's negative. Okay, let's go ahead, move on to the next one. On here, we are identifying all of the following key characteristics. So domain, range, relative max, relative min, increasing interval, decreasing interval, and behavior. And it doesn't say odd, negative, positive, even, but I will tell you this graph is odd and it is positive. So let's go right into it. So domain, remember your domain is how far left to right this goes. If I were to take this actual graph right here, whoop, so if I took that actual graph and I stretched it out this way, it would extend forever and ever because it is at a slant. So my domain is going to be all real numbers. I also can look at it, and if I stretched it top to bottom, what is happening? It's also extending forever and ever, so the range is also all real numbers. Okay, now I'm looking at relative max, relative min. So remember, our relative max is anywhere this graph curves upward. And I'm actually going to put that like that. So anywhere right here and right here, these are both relative max and mins. So the max is the most high point in that area. So this one would be my max. So that is the point, negative 1, 2, 3, 1, up 1, 2, 3. So negative 3, 3. My min is this one right here. So what is that? That is -1, -1, 2, 3. So -1, -3. Okay, erase this. Notice I'm not erasing my highlight of my min and max because we need that for increasing and decreasing behaviors, intervals. So right here, I am gonna change. So remember, this graph is increasing right here up till that max. It's also increasing again right here. It is decreasing right here. Okay, so I'm looking at the distance on the x-axis. So from where does it start to where does it end? So right here, it is positive all the way up until here. And then let me put a little line right there. Right there. Okay, it is negative from this spot to that spot. There we go. Okay, let me put a little tick mark right there. Okay, and then it is positive again all the way right there. Okay, so let's go ahead and write those intervals. So the first set of green is increasing from -infinity, because I don't know where the start is, all the way to -3, which is the x value. So you should notice that we're using our x values of our min and max. So -3, and then it's also increasing from -1 to positive infinity. My decreasing interval, so when is it falling? It is falling from -3 to -1. And remember, I should be able to put the increasing interval and decreasing interval together to make it go from -infinity to infinity. Okay, so now I'm going to get rid of this stuff. Doop, doop, doop. Doop. Okay, now we're looking at end behavior. So end behavior, end behavior. So on the right side of the graph, what is happening? It's facing up, so it's going towards the positives. The other one, as the left side of the graph is getting more negative, it is facing downwards, so towards negative infinity. Okay, next one. Determine the zeros and multiplicity of the following function. So we're going to get right into it. Remember, to determine your zeros and multiplicity, I actually need to factor first, and then I'm looking at the exponent for multiplicity, and I am solving each factor to find my zeros. So let's go ahead, get right into it. Divide by x squared, because that is my GCF. So x squared, parentheses, we've got x squared, we've got -16x, and we've got +64. Okay, let's go ahead and on the trinomial, so just the trinomial, we're going to do x method, which I'm going to do off to the side. That way I leave myself room. Okay, so what two numbers multiply to give you 64, but add to give you -16? That would be -8 and -8. Okay, so let's go ahead and remember the way we write this is x squared, parentheses, x -8 squared. Okay, so we are going to separate x squared equals 0, x -8 equals 0. Right here, square root, square root. The reason why we're not doing the square root on the x -8 squared is because of what I'm going to show you. Taking that square root is just going to make it 0, so we're just saving ourselves an extra step. +8 plus 8, x equals 8. Okay, so my two zeros for this graph are 0 and 8. my multiplicity for both is 2, because I had x squared, because remember, I'm looking at this one right here. I had x squared, and I had x minus 8 squared. So multiplicity 2 and 2. And your multiplicity, when I add them together, they should equal my highest exponent. So 2 plus 2 is 4. Oop, I don't know why I crossed that out. I meant to highlight. There we go. So it should be 4, and it is. 2 plus 2 is 4. Okay. Remember, the only other thing you need to know is behavior. So multiplicity behavior, I'm looking at, so I'm looking at this. So we've got 2 and 2. So when the graph reaches 2, is it crossing, intersecting, or bouncing? So this one is when we have an odd, it's going to cross, but when we have an even, it's going to bounce. So both of these are the same. They're both, and I'm gonna draw myself a quick little graph. They're both gonna bounce, and this is a positive graph even. So at x equals 0, it's gonna bounce. At x equals 8, it's also gonna bounce, okay? So bounce for both. And that's it for that. So let's go to the next one. Number 5. I'm gonna go ahead and erase this word, just so it's not in the way. I'm gonna erase some of this too. There we go. Okay, so again, all the key features of graph. So right here, domain and range. This one is extending left to right forever and ever. Oh, I don't like that I didn't give you an even graph for domain and range. So, oh, my bad. So remember, if a graph looks like this one, there is going to be a range. This one would be y less than equal to whatever this high point is, whatever my max y value is. Okay, so that's domain and range. Just remember, if it cuts off, it does have a boundary. So this other one I'm looking at, this one, both the domain and range are all real numbers because it extends left to right, top to bottom, infinitely. So we're good there. Okay, next one, relative max. So our top point, relative min, low point. Okay, so relative max is going to be, this one is 3, 0. Relative min is 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, negative 4. And let me just double 1, 2, 3, 4. Yep. Okay. The only other thing I did not add to this, which I wish I would have, is your zeros or solution. So remember, these are your x values. So this one we have 3, 0. And we have 1, 2, 3, 4, 5, 6, 6, 0. Okay, let's do our increasing, decreasing. Oh, low power mode. Let's do increasing and decreasing intervals. So right here is what we care about. Okay, so increasing, green. This one is increasing right here and right here. It is decreasing right here. And I really hate that I didn't give you guys an even graph. I might have to do that, or we might not have time. Okay, so decreasing, increase, increase. Let's go ahead and write this. So it is increasing from negative infinity all the way to 1, 2, 3. The x value of my max is 3. And it's increasing again. The x value of my min is 5 to infinity. And then where is it falling? It is falling between 3 and 5. And again, you're really just looking at your x values on your min and max. That's going to be your best friend for this. Okay, end behavior. So ends, boop, boop. So as the first one is going towards the positives, what is happening to the other one? It's going towards the positives. Okay, as this one is heading towards the negatives, and our domain is all real numbers, which is how I know, even though it's not on the left side of the graph, it is heading that way. Like, you see how close these two are? It's eventually it's going to cross and then head into that left side. So as it's heading that way, it is negative infinity. Okay. Last problem before my iPad dies. So right here, write a function that has a 0 of 4/5, multiplicity of 2, a 0 of -3, multiplicity of 1, and a 0 of 4, multiplicity of 1. So we're going to set up with x equals 4/5, x equals -3, and x equals 4. Okay, let's go ahead and start with the first one. This one, we're going to multiply by 5 on both sides because we want, remember, during this process, we want to get rid of one number at a time. So this is going to be 5x equals 4. Okay, well, how do I move 4 over? I'm going to minus 4, minus 4. So 5x minus 4 equals 0. On the next one, I'm going to add 3. So x plus 3 equals 0. On the last one, I'm going to minus 4. So x minus 4 equals 0. So now that we've got them all set to equal 0, we are going to set them right next to each other. So 5x minus 4 in parentheses, x plus 3 in parentheses, x minus 4 in parentheses. Okay, my multiplicity of 4/5 was 2, so we're going to put a little 2 right here. My multiplicity of the other two was 1. So, I mean, essentially you could put 1, but that's not going to make a difference. Still the same thing. We're just going to leave it like that. I will not count off if you do put a 1. However, that's all I'm doing. Okay, I do want to talk a little bit about this first graph, the second graph right here. So remember, when you have an even graph, you're going to have multiple, okay. You're going to have multiple increasing. So right here, you should have about 2 of each. Odd graphs, you typically only have 1. So you're going to have about 2 increasing intervals, 2 decreasing intervals. And you just use the x values of the min-maxes to determine that. Remember, your first boundary should be negative infinity. Last one should be positive infinity. And that's really it. Good luck on your test. And yeah.